Hi all! In this video, we are going to discuss some 1-mark questions from real numbers. These are the questions I will be solving in this video. Please pause the video here and attempt the questions before continuing further. The first question. Check whether 6 to the power n can end with the digit 0 for any natural number n. One way of doing this is to check what 6 to the power 1 is, 6 to the power 2 is, 6 to the power 3 is, and so on. 6 to the power 1 ends with 6, 6 square ends with 36, 6 cube is 216, this ends with 6. Now we can see here that 6 to the power n would never end with the digit 0. Rather, it always ends with the digit 6. However, the commonly accepted answer in your school and in the board exam when it comes to this question is 6 equals 2 into 3, which means that 6 to the power n would be 2 times 3 to the power n, or 2 to the power n into 3 to the power n. Now, by fundamental theorem of arithmetic, 6 to the power n has only 2 and 3 as prime factors. What this means is that 5 is not a prime factor. Now, why was it important that we are checking whether 5 is a prime factor or not? Because any number can end with digit 0 only if 10 is a factor. 10 to be a factor, 2 and 5 both must be factors of the number. We got 2 here, but 5 is missing. And hence, the number cannot end with 0. Let's look at the second question. Given that HCF of 306 and 657 equals 9, hence find the LCM of 306 and 657. Here we use the property that HCF of two numbers times the LCM of the same numbers is just the product of the two numbers. We need to find what is the LCM of 306 and 657. So LCM of 306 and 657 would be equal to 306 times 657 divided by the HCF of both these numbers. Now, many of you might actually calculate this. You might spend time in calculating what 306 and 657's product is. That's not necessary. Leave it as it is and divide by the HCF. When you do the same, you would be able to get that this is 34 times 657, which is 22338. The fourth question. Without actual division, find the decimal representation of 39 by 1200. In such questions, ensure that you are simplifying the numerator and the denominator to the lowest form possible. Reduce both of them. Here we can see that both the numerator and the denominator are divisible by 3. You would get this as equal to 13 by 400. Now let's prime factorize 400. 400 would be the same as 2 to the power 4 into 5 square. How did I do this? You have 4 times 25. 400 is 4 times 25 because the 100 is just 4 times 25. 4 could be written as 2 square. This 4 can be written as 2 square and the 25 would become 5 square. Here we can see that the only prime factors are 2 or 5. We do not have any other prime factors, which means definitely it is a terminating decimal. And how do you find the decimal representation? This rational number could have been written as 13 by 2 to the power 4, 5 square. The easy way to do the division over here without the actual long division is to try getting denominator completely in powers of 10. You've got 2 to the power 4 here. when you multiply by 5 square the denominator as well as the numerator, you will get 13 times 25 divided by 2 to the power 4 into 5 to the power 4, which is 13 into 25 by 10 to the power 4. What's 13 into 25? 13 into 25 would be the same as 325. And this 325 gets divided by 10 to the power 4, which would be the same as 0.0325, and this would be the decimal representation of 39 by 1200. Fifth question. If two positive numbers a and b are expressed in the form a equals pq square and b equals p cube q, p and q being prime numbers, find the LCM of a and b. You're having a, which is pq square, b is p cube q. How do you find the LCM? The LCM would be product of all highest powers of prime factors. We are already given that p and q are prime numbers. When you take power of all highest powers of prime numbers, look out for the higher power of p, that is p cube, and look for the higher power of q, which is q square. So our answer would be p cube q square. That's it for this video. Thank you for watching. Bye-bye.